Welcome back. This is Teresa Adams with the Community College of Denver. And what we're going to do today is we're going to finish up our double and half-angle identities. So we're going to start out with the sine of 13 degrees, cosine of 13 degrees, and they're asked us to use the correct identities to just simplify. They're not asking for answers or anything, like they're not asking for exact values or they're not asking for approximate values. They just want us to simplify it. So we have the sine of 13, cosine of 13. That means that we have a double angle. So this is equal to the sine of 2 times the 13 degrees, which means this is the sine of 26 degrees. As we take a look at our second one, it's the same kind of format as the sine of pi ninths minus pi halves, cosine of pi ninths minus pi halves, which means we can just rewrite this as 2 the sine. And then when we do pi ninths minus pi halves, we get negative 7 pi over 18, cosine of negative 7 pi over 18, which means this is the sine of 2 times negative 7 pi over 18, which is sine of negative 7 pi over 9. And because sine is an odd function, we can write this as the negative sine of 7 pi over 9. Now as we take a look at our last example, I just really liked cosine a lot, so I wrote it twice, but we don't really need that first one, so let's cross that out. And I have the sine of 12 degrees and 1 plus the cosine of 12 degrees, and we know this is the tangent. And so this is going to be the tangent of 12 degrees divided by 6. Excuse me. Man, I guess I like 6 today too. Probably because I know what the answer is going to be. So let's try this again. It's going to be 12 degrees divided by 2, which is the tangent of 6 degrees, which is what I wanted to give you in the first place. Okay, so let's take a look at our last 3 examples. And now we're going to find exact values using the sine of 2 alpha, the tangent of 2 alpha, and the cosine of 2 alpha. So on these, I need the fact that I know the sine of 2 alpha is going to be 2 the sine of alpha cosine of alpha. And as I look at this, I already have the sine of alpha, so all I need to do is find the cosine of alpha. We're in quadrant number 2, and so when I take a look at alpha, the sine of alpha, I know my y is 3, I know my r is 5. That means my x is the negative 4, because this is a 3, 4, 5 type triangle. So that means that this is going to be equal to 2. My sine of alpha is 3 over 5. My cosine of alpha is negative 4 over 5. And then I'm just going to multiply the 2 times the 3, which is 6, times the negative 4, which is negative 24. And on my denominators, I get 25. Now, as I take a look at B, I have the sine of alpha is equal to negative 4 over 5. I'm in quadrant number 3. So I have y equals negative 4, r equals 5. And because I'm in quadrant 3, x is also going to be a negative number, and it's going to be negative 3. So when I find the tangent of 2 alpha, I have a couple of choices. This choice, I'm going to take the tangent of 2 alpha. I'm going to make it equal to 1 minus the cosine of alpha over the sine of alpha. And so I have 1 minus, my cosine is negative 3/5. My sine is negative 4/5. I can't leave fractions with fractions. So I multiply everything by 5, and I get 5 plus 3, because the double negatives, over negative 4, which gives me 8 over negative 4, and so my answer is negative 2. Now as I take a look at this last one, on the cosine of 2 alpha, I have a bunch of choices. But because of the fact that they're giving me the sine of alpha, I'm going to use my easiest way out. And I know the cosine of 2 alpha is equal to 1 minus 2, the sine squared of alpha. That means I don't have to find the cosine of alpha. I can just go right to it. So this is going to be equal to 1 minus 2, 8 over 17 squared, which is going to be 1 minus 2, 64 over 289, which means I get 161 over 289. And thank you for watching.